Normally, a two-engine airplane must stay within 60 minutes flying time of an adequate alternate. This rule restricts the area of operation and may result in increased route distance and fuel. For instance, consider a New York to Madrid flight under the 60-minute rule. However, if an operator meets ETOPS requirement, he may fly in areas that are 120 or even 180 minutes from a suitable alternate. ETOPS operation increases the routes available to economical two-engine airplanes. ETOPS operation requires two levels of regulatory approval. First, the airplane manufacturer must obtain a type design approval for the engine-airframe combination. Then, the airline must obtain operational approval from their regulatory authority. Type design approval is based on engine reliability, system design and reliability, and a validation test flight. Engine reliability is measured by in-flight shutdown rate. For an engine to qualify for 120 minutes ETOPS, most regulatory agencies require less than 5 shutdowns per 100,000 hours of operation fleet-wide. For 180 minutes ETOPS, the typical requirement is less than 2 in-flight shutdowns per 100,000 hours of operation. The airplane may require additional equipment to meet the system design and reliability standards for ETOPS. The APU is normally upgraded to improve reliability and improve in-flight starting performance. On some models, a hydraulic motor generator has been added to increase dispatch flexibility for ETOPS. If required, the HMG provides an additional source of AC electrical power. The highlighted flight deck equipment is available with the HMG as the only source of electrical power. Electronic equipment cooling systems have been upgraded. Cargo fire suppression time must be increased to meet ETOPS requirements. The final step in obtaining type design approval involves a manufacturer's validation test flight. This test flight verifies the airplane's flying qualities and the flight crew workload with various systems inoperative. This test flight also is used to verify the airplane's ETOPS-related performance. To obtain operational approval, the airline must show that they have operational and maintenance programs that address ETOPS requirements. This includes additional training for flight crews and maintenance personnel. The airline ETOPS operations program must include route planning, dispatch considerations, and an operations specification. An operational validation flight may also be required. An airline ETOPS maintenance program must include the identification of ETOPS-related tasks, ETOPS parts control program, monitoring of the airline's in-flight shutdown rate, an oil consumption monitoring program, and an engine condition monitoring program. This program will identify engine anomalies before they become a problem. This will also reduce the possibility of a problem during a prolonged single-engine diversion. An important item in an ETOPS maintenance program is the similar task concept. If a similar task has been done on 2 separate but similar ETOPS critical components and a satisfactory ground test does not exist, a maintenance verification flight may be required. This verification flight is to ensure that the problem has been resolved and that identical maintenance errors have not been introduced to both components. Examples of this are the improper installation of O-rings on a chip detector in both of the engines during routine maintenance or the removal and replacement of both the left and right engine fuel control modules. The required verification flight may be performed during a non-ETOPS portion of a scheduled revenue flight.